Hello, hello. So I'm here to do the second part of the Lesson 9A video where we talk about finding a necessary sample size. So when we are given a margin of error and we want to find what sample size we would need in order to get that certain margin of error. So let's suppose you want to estimate the mean amount of money spent on prom by McNeil High School students with a 90% confidence interval. You plan on taking a sample of students who went to last year's prom, and based on data from previous years, you have a good idea that the standard deviation of the money spent is about $45. If you want the margin of error to be no more than $10, how many students should you survey? So again, the idea with this type of problem is we have this margin of error in mind. We really want to be able to estimate this true average amount of money spent within $10 because we want to be super, super accurate. So, as a reminder, our margin of error is basically everything that comes after the plus minus in our confidence interval formula. It's the critical value times the standard error. So margin of error for this type of problem, right, was T star, because for means we use T. So T star times the original standard deviation divided by square root of n. Now here's the problem with that. T star is based on a degrees of freedom, right? T star is different for a confidence level depending on the degrees of freedom. And degrees of freedom is based on sample size. If I don't know what sample size to take yet, that's what I'm trying to find out is my sample size. There's no way for me to know what T star is because I don't know my sample size yet. And then furthermore, S is technically the standard deviation of the sample. Again, I haven't taken the sample yet, so I don't know what the standard deviation of the sample is. So what that means is in order to do this type of problem where we make this estimation for sample size, we're having to use the Z version of this formula. So Z star times original population standard deviation, which means that we have to have some idea of the population standard deviation. So that's why it says, based on previous data, we have a good idea that the standard deviation is about $45. So we're trying to get an idea about what the true mean is, but in order to do that, we have to have some clue about the standard deviation. It's really the only way to answer a question like this. So from here on out, it's plugging in values. So in this case, my margin of error that I want is 10. So I would plug that in for margin of error. Z star comes from the confidence level, so 90% confidence level. And again, because this is a Z star and not a T star, we would do this back how we used to with proportions. So Z star for 90% is 1.645. And then my standard deviation for the population is 45. N is what I'm solving for. So I'm going to plug all that in. So 10 was my margin of error that I wanted. 1.645 is my Z star for 90% confident. 45, and then square root of n is what I'm solving for. From here, it's algebra. Just to go through the steps of the algebra, there's a couple different ways that I could do this, but I would start by dividing by 1.645 on both sides so that it cancels out on the right. My next step is I notice I have a fraction equal to a fraction, so I'm going to do a little cross multiplying. So 10 times square root of n equals 45 times 1.645. I always like to save my mathiness for the end of the problem so that I'm not rounding. So my next step is I would divide by 10 on both sides so that I have 45 times 1.645 divided by 10 is equal to the square root of n. And then my last thing to get rid of the square root would be to square both sides. Okay, so now that I have it down to that, I can go to my calculator and I can just type that in. So let me do that real quick. All right, so I have typed that in. Notice that I made sure to put parentheses around that whole fraction. 45 times 1.645 divided by 10 is all in parentheses, and then I squared it. And that gives me a value of 54.8. If you remember back from when we did this with proportions for this type of problem, we had talked about, right, 54.8 is not really possible. I can't really ask 0.8 of a student, how much money did you spend on prom last year? So I always need to round, and because we are trying to guarantee a certain margin of error, we never want to round down because a smaller sample size is always going to mean a larger margin of error. So in this type of problem for sample size, I'm going to round up, to 55. Now on this problem, obviously it makes sense to round up because 0.8, I would round up. But even if that were like a 0.2, I would still round up. So 55 students is how many I need to ask to guarantee that my margin of error is no more than 10. So just one more example of that. Suppose we want to estimate the mean SAT score for AP Stat students at McNeil with a 98% confidence interval. The standard deviation of scores for all McNeil students is thought to be 195 points. If we want the margin of error to be no more than 25, what is the desired sample size? So again, I'm starting with that base formula, using the Z version of the formula because it's the only way I can do this problem. Plugging in what I know, right? Margin of error is 25. Z star for 98% is 2.326. And again, that's just calculated the same way we did last unit. You can use inverse norm on your calculator. And then standard deviation of the population is 195. We're solving for n. Just to kind of change things up, I did the math slightly differently just to show you there's different orders. So with this one, I noticed that, right, it's just a whole number times a fraction. I can multiply the tops of the fraction because the bottom of this one is just a 1. So if I do that first, kind of rewrite it to look like this, then I can do that little trick where I'm basically switching the 25 and the square root of n, kind of multiplying by square root of n and then dividing by 25, which gives me this. And then I can go straight to squaring both sides to get there, right? So that's just a little bit of a different / faster way to do the solving part. Again, I would type that into my calculator and I would get a value of 329.2, but we always round up because 329 may give me a margin of error that is slightly too big. So I always want to round up. So I'm going to say 330 students. So that is how I find sample size from a margin of error, do that little bit of solving. All right, and that is it for this part of the lesson. It's a short one.